Okay, good morning. All right, we left off talking about statistical tests and p-values, okay? I don't think I gave this to y'all in second hour here. So write down those formulas for me, please. Those two formulas for z and t are the values of your standardized test statistic. Okay, so you get a test statistic. Pretty sure it's usually given to you, or you have to calculate it from your sample. Okay, and then so like for our test statistic for a population will be this x bar, or for a population parameter is going to be x bar. So that's where the x bar comes in this formula. Okay, the mu part will be from your hypotheses. Okay, so like sometimes you'll write like, you don't have to write this down, but if I write like HO mu is greater than or equal to 15, the mu for here would be 15. Okay, and then either sigma or S will be given depending on whether or not you know sigma or if you know your sample or your population standard deviation, and then you'll have n as well. Okay, so now what does this help us do? We're about to talk about that. It helps you. The standardized test statistic helps you find what we call our p-value or probability value. So p stands for probability. Okay, so what is p-value? If the null hypothesis is true, a p-value of a hypothesis test is the probability of obtaining a sample statistic with a value as extreme or more extreme than the one determined from the sample data. Okay, so when you get your standardized test statistic, you're going to have an area under your curve that is formed by the standardized test statistic. Okay, that area under that curve will be your p-value. Okay, and it's going to come in the form of some type of a tail, a left tail, a right tail, or two tails. Okay, so the p-value of a hypothesis test depends on the type of test that we're doing. We do have three types of tests: left-tailed, right-tailed, or two-tailed. Okay, so left-tailed, right-tailed, or two-tailed. All right, you might ask, hey, how do I figure out what type of a test it's going to be? Okay, well, it says right below here that the type of test depends on the location of the region of the sampling distribution that favors a rejection of your null hypothesis. That's a lot of words. Here's how you're actually going to figure it out. Okay, this region is indicated by your alternative hypothesis. Basically, what symbol you use in your alternative hypothesis tells us what type of test you're going to be using. Okay, so for a left-tailed test, we have, notice over here, for a left-tailed test, the tail is where? To the left, okay? Your p-value is the area inside of that tail, okay? Which is the area to the left of the standardized test statistic. So that value that you calculate with that formula will create the tail, okay? And since this is a left-tailed test, it would be the area to the left, okay? We know it's a left-tailed test because we look at HA, and what symbol do I see in HA? Less than. So to determine if it's a left-tailed test, okay? So if your HA contains a less than symbol, then we have a left-tailed test. The type of test tells you how you are going to determine your p-value. Okay, so for instance, if it's a left-tailed test, the way I'm going to find my p-value is I'm going to look up my standard, if it's a z, for this is how you do it for z. I don't think we use p-values for see, I don't remember right now. But anyway, okay. So I would like say we use z. I would look up the z score from my standardized test statistic that I calculated. I would look it up in my z chart, and it would just tell me the left area, and that would be my p-value. Okay. So we're going to go over that again when we actually get to doing a test, but this is just kind of touching on it right now. Okay. So the main thing we need to know right now is if your HA contains a less than symbol, then we have a left tail test. Okay. If your HA contains a greater than symbol, then we have a right-tailed test. So then my p-value is going to be the area in the tail that's to the right. Now this one's going to be a little bit harder to find, right? Because if I looked up this value in my Z chart, it would tell me what area. It would tell me all this area right here. So what would I have to do to find the area of the blue? 1 minus that, right? Okay, good. So if it's a right tail test, you have to do a little bit more work to find the p-value. Okay, and then we have a two-tailed test. Because how many tails do we have in a two-tailed test? 2. What symbol do you think we're going to be using for two-tailed to look at it? Not equal, okay? So if your HA contains a not equal sign, then we have a two-tailed test. Okay, so for a two-tailed test, look at this. How many standardized test statistics do we have for a two-tailed test? 2. Can you guess what they're going to be? They're going to be probably the same number, but one is positive, okay? So what I'm probably going to do to find the p-value for a two-tailed test, okay, no matter what I calculate, if I calculate my standardized test statistic and I get a negative, that'll be this one, and then the other one would be just the positive version of that. If I calculate it and I get a positive version, the other one will have a negative to it, okay? So the best way to find the p-value for a two-tailed test is you're going to take that negative standardized test statistic, look up the area in the chart, okay? And then what do you think you're going to do to it to get the entire p-value? I know this one, these two are going to be the what? The same area. Agreed? Because we're symmetric, right? So if I find this area, I just double it, and that gives me the p-value. Because we're dealing with normal distributions here. So, okay. So the areas of each of these tails is 1/2 of your p-value. So if you add them together, that gives you your total p-value. Okay. So like whenever we start doing this, you're going to take that negative standardized test statistic, look up its left area, and then since these two are the same, just double that and you get your entire p-value. Okay. But again, we'll talk about that more when we get to 7.2 on Monday. Okay. Questions about how to figure out what type of test it is. That's really all we're dealing with in terms of this. You're not going to have to find any p-values for 7.1. Okay. We'll wait to find p-values for 7.2. But I think it's nice to at least introduce it right now for you to get an idea of what we're going to be doing. All right. So for example 3, it says for each claim, state your 2 hypotheses, then determine whether the hypothesis test is left-tailed, right-tailed, or two-tailed. Then sketch a normal sampling distribution and shade the area of the p-value. Okay, so I honestly think we've already done these, already made these hypotheses. We did them yesterday, so but we'll just do them again. Okay. A school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. So my claim is P equals 61%. Is that going to go as HO or HA? HO, right? So P equals 0.61 and P does not equal 0.61. And remember that we just take the opposite to find of the one that we're given to get the other one. Okay? So this is our claim. And that's so what type of a test am I going to have here based off of my HA? Two-tailed test, right? Because it comes straight from the fact that this is a not equal sign. So when I sketch my sampling distribution, draw out a little bell curve, and how many tails am I going to shade? Where am I going to put the two tails? In like approximately the same location on both sides, right? Don't do this. This is not what you don't want like this, right? Where they're obviously not in the same spot. Okay, so here we go. That's all we need to see for, because we don't know what our standardized test statistic is or anything. So if we don't have any more information we can put on there right now. All right. A car dealership announces that the mean time for an oil change is less than 15 minutes. So mean less than 15 minutes. Okay. So mu is less than 15. HO or HA? HA. Right, because strictly less than goes for HA. And this is our claim. So mu is greater than or equal to 15 would be my null hypothesis. Do I have a left-tailed, a right-tailed, or a two-tailed test here? Left-tailed, and that came from the less than symbol in my HA. Always look at your HA to find what type of test it is. So there's your sketch. Okay. Lastly here, a company advertises that the mean life of its furnaces is more than 18 years. So HO, HA. So mu is greater than 18. That gives me my HA. That's my claim. So for this one, we've got a right tail test. And my drawing looks like a right tail. Super hard, yes? Questions on how to determine the type of test that we will be dealing with? All right, next. Yes. Well, you're about to see it actually is going to make a big difference because when we make our decision and interpret our decision, it depends on what is the claim. Okay. So that's probably going to be points off from whenever you write the thing and your interpretation as well. Okay. So that's why I say it's important to do that because because at the very end of your hypothesis test, you're going to have to write a complete sentence, which is an interpretation of your decision that you make at the very end. Okay. And we use very specific wording based off what your claim is and whether you're rejecting or failing to reject the null hypothesis. Okay. So this is literally the next thing. That was a great question leading into the next thing. Okay. So the question was, how many points off is if you don't put the claim on your thing? So you need to do that. Okay. All right. So, to conclude a hypothesis test, you make a decision and you interpret that decision. Okay, that's like two steps of the hypothesis test. One of them is to make the decision, and the next one is to actually interpret that decision. Okay, because what good does this do if we don't know why we're doing this? That's what the interpretation does for us. Okay, so for any hypothesis test, there are two possible outcomes that we've already talked about. Your first outcome could be to reject the null hypothesis, or you can fail to reject the null hypothesis. However, we have to figure out whether or not, how do we know if we're going to reject or fail to reject? Okay. Now, there is a decision rule we can use that's based on our p-value that we just talked about how to find. Okay. So I think when we get to 7.2, there's also another decision rule that we can use with what we call rejection regions. Okay. But for right now, we'll just focus on p-value. And again, we will reiterate this again when we get to 7.2. Okay. So to use a p-value to make a decision in a hypothesis test, you're going to compare the p-value with alpha. And alpha is our level of significance. And this value will be given to you. So like in the prompt for the hypothesis test, it'll be like, perform a hypothesis test for a level of significance of this much, or something like that. Okay, so once you've calculated your p-value, if your p-value is less than or equal to your level of significance, then you reject. Okay, otherwise, or if p is greater than your level of significance, then we fail to reject. Okay, so we made a decision either to reject or fail to reject. Now we have to write our sentence that interprets the decision that we've just made. Okay, so like I said, there is specific wording that I'm going to want to see whenever you write your interpretation. Okay, so this chart right here, this table, please put some big stars next to it because it'll be very important. I'm going to have you reference back to this table throughout the rest of this chapter to help us know how to write our interpretation sentence. Okay, so let's see what it breaks down. Okay, on this right here, we have our decisions, and right here we have what our claim is, which is why what the claim is going to, knowing what the claim is, whether it's HO or HA, is very important. Okay, if our claim is the null hypothesis and we end up rejecting the null hypothesis, the wording that you're going to use is there is enough evidence to reject the claim that, and then you finish restating your claim in words. Okay, so if the claim is the null and you reject the null, then you say there is enough evidence to reject, which makes sense because you're rejecting the claim, which is HO. Okay, now if you fail to reject the null hypothesis when your claim is the null hypothesis, the only difference in the wording is now there is not enough evidence to reject the claim that ... Then you finish. All right, so that's if your claim is the null hypothesis. What happens if your claim is the alternative hypothesis? The wording changes a little bit. Okay, if you reject the null when your claim is the alternative, you're going to say that there is enough evidence to support, that's the difference here, the claim that. So if you're rejecting null, you are supporting the alternative. And then if you fail to reject the null hypothesis when your claim is the alternative hypothesis, there is not enough evidence to support the claim that. Do we see a pattern here? So if your claim is the null hypothesis. In your interpretation, will you use the word reject or support in there? Reject. Notice that in the first column, both of those sentences have the word reject in there. Now, if your claim is the alternative hypothesis, what's the wording you're going to use? Support, support. Now, your question may be, how do I know if it's there is or there is not? That depends on whether you reject or fail to reject. If you are rejecting, then it's always going to be there is. If you're failing to reject, it's always going to be there is not. There is not. Okay? You have 4 choices for your wording, and it depends on your decision and what your claim is. Okay? On the test, I do not want you to just stop right here. You're going to have to finish this sentence for me too and restate what your claim is. Okay? So let's look at an example. Okay? You perform a hypothesis test for each claim. So you can look at number 1 and number 2 here. We're both given claims. Okay? And one of them's HO, one of them's HA. Okay? In both number 1 and number 2, you're going to do 2 things. For part A in each of them, how should you interpret your decision if you reject HO? Basically, what's the wording that you're going to use if you reject the null hypothesis? And in part B, what is the wording that you're going to use if you fail to reject the null hypothesis? And you're just going to choose the correct statement for each. So number 1, the claim is your null hypothesis, and the claim is that a school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. So for part A, since we know our claim is HO and we're rejecting HO, based on the chart, what's the wording we're going to use? There is enough evidence to reject. So which one of these is that? A is correct. This one says there is enough evidence to reject. This one says there is enough evidence to support. This one says, C says there is not enough evidence to reject, and D says there is not enough evidence to support. So the only one that says there is enough evidence to reject is A. And then if we're failing to reject, okay, so also another way to approach this with this one, since the claim is HO, any one of these that says support, I can say it's not going to be that for sure, right? Okay, so B and D are not going to be any of my answers. So if we're failing to reject, that means we do the is not and then reject. So that's going to be C. So notice that they don't stop right here when they write their sentence either. They say there is not enough evidence to reject the school's claim that the proportion of students who are involved in at least one extracurricular activity is 61%. So you're going to have to write a nice, pretty sentence like that at the very end with correct grammar to an extent. Okay? This statistics sometimes is, if you took AP Stat, they do a lot of writing in AP Stat, which is why I don't want to teach AP Stat. Okay? All right. For number 2 here. Actually, you know what? You go ahead and do number 2 on your own. It'll probably take you a minute to do, okay? Got it. You want to say hey?
Hey.
All right. So we're done? Yeah? Okay. What's the claim here? HO or HA? So I can get rid of what 2 choices? A and C automatically because they have the wording reject in there. I only want to see support. Okay. So if I'm rejecting the null and my claim is HA, I'm going to say there is enough evidence to support. So that is B. And then if we're failing to reject, we add that little not in there to get choice D here. All right, questions on the wording, okay? All right, so don't lose these notes because we're gonna, as we go to through 7.2 and 7.3, I will have you take out your notes and refer back to this chart. Sounds good? Let's go. Moving on. Last thing. All right, so here are steps for hypothesis testing in general using p-values. Because there are other steps that don't use p-values to do a hypothesis test. Okay, so this one does use p-values. All right, but the first step, honestly, always for any type of hypothesis test that you're going to do is to state your hypotheses and identify which one is the claim, okay? So again, we see the importance of getting the claim correct and getting the hypotheses correct, because if you don't get the hypotheses correct, obviously your sentence is going to be wrong, your decision you make is going to be wrong, all this stuff, okay? The type of test that you have is going to be wrong if you do not write your hypotheses correctly. So I can't state how important step one is, okay? Because everything gets messed up if you do that incorrectly, okay? And then I have to pretty much take points off for everything from there, okay? It's easier to make a little bit of a mistake somewhere else, but I'm Papa right in all caps. Very important. So if you cannot do this, you need to come talk to me or something so we can figure out and help you figure out how to do that better, okay? So this is very important that you are able to state your hypotheses correct. Okay, the next step will be to specify your level of significance, your alpha. Okay, this will be given. So you're going to have to read your problem and figure out what the level of significance is from the wording of your problem. Okay, then you're going to determine the standardized sampling distribution and sketch its graph. Okay, so this part right here, when I say sketch its graph, it's basically shade in the correct tail. Okay, so I will know this from whether or not it is a left tail, a right tail, or a two-tailed test. And how do we determine what type of test it is? What hypothesis do you look at? HA. So I guess we could write that on there as well. Look at HA. Keep writing like ha. I need to put this subscript like down a little bit lower. There we go. If it's not H, then A. It's H sub A. All right. So then you will calculate your test statistic and its corresponding standardized test statistic. Now, when it says calculate the test statistic, that's going to be your X bar that we're dealing with. Okay. Oftentimes, you won't actually have to calculate it. It'll just be given to you in the problem. But if you do a hypothesis test and it gives you a sample of values, you will have to calculate the test statistic. But I think for my tests, all I've done, I've actually just given you the sample mean. Okay, so that's the sample mean. X bar is going to be the test statistic for our hypothesis test we're doing. But you will have to calculate this, okay, with a formula. And let's go ahead and write down the formulas again. Okay, so if sigma is known, then your formula for your standardized test statistic is Z is X bar minus mu divided by sigma over the square root of n. Okay, if sigma is unknown, we're going to use what? T. And so if sigma is unknown, guess what's going to be known? S. You use T equals x bar minus mu divided by S over the square root of n. And you'll be using your T distribution in this case. For this one, you'll be using your standard normal distribution, which is the Z chart. This one, you'll use the T chart for your T distribution. All right. Then you find the p-value. This is just the area of the tail. Or tails. Because we do have one that has two tails on it, right? Okay, so once you have found your p-value, then we're ready to make a decision. Okay? Is the p-value less than or equal to the level of significance? It's asking, is p less than or equal to alpha? If we say yes to this question, then we reject the null hypothesis. If we say no, then we're saying that p is greater than alpha, right? Because if it's not less than or equal to alpha, it has to be greater than alpha. So then we fail to reject the null hypothesis in that case. Okay, so we made a decision. Now our decision does us no good unless we can interpret that decision. So in our last step, we write a statement to interpret the decision in the context of the original claim. So you use that table that we talked about. Okay, basically saying there is or there is not enough evidence to either support or reject the claim that, and then you finish your sentence. And that's it. We're going to skip example 5 because I think actually it does a little more harm than good. Okay, so that's it. Thank you for watching.